Hi everyone. In this video we're going to do some examples, and the examples are related to when we did the mole definition. And so we're going to do some examples with molar mass and moles, grams, number of molecules, using Avogadro's number and so on. So that's the idea, just to get us familiar with doing that and to help you with the homework for chapter 3, where you'll be doing some of those conversions. So the example I've got is, let's say we have a sugar cube, and that sugar cube weighs 32 grams. Okay, and sugar is sucrose, which has this formula, C12H22O11. So a pretty big molecule, right? And so the meaning of that formula, now I know that, again, sometimes I feel silly doing this, but it's important that everyone's on the same starting point, right? And so I know that most students probably already know this, but I'm going to always try and do things from the beginning. And if that's boring for some students, that's okay, because I want to help everyone, especially the students who I know in the past have struggled. There's students who struggle with things. So that's the idea with why I go into it, and hopefully in so much detail. If I ever don't have enough detail, or you feel like something's left out, or you need more help, that's when I need you to post your question to the discussion group. So this formula, when we read a formula like that, what that formula means is that in that molecule of sucrose, we have 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen in one molecule. But just like we did with molar masses and atomic masses, if we had a mole of this stuff, we would say we've got 12 moles of carbon in 1 mole of this, 22 moles of hydrogen in 1 mole of this, 11 moles of oxygen atoms in 1 mole of this. So it scales up in the very same way. And sometimes that's confusing to people. Well, how can you have 1 mole of this and get, all these other moles? Well, just the same way you can have 2 slices of bread and a slice of cheese on a sandwich, right? You get 3 things, it's 1 sandwich. And it really is that simple. It's just a matter of counting. But because it's chemistry, because we'll have odd looking numbers, it gets a little confusing sometimes. Okay, so that's in 1 molecule of this sucrose. And so a few examples that we'd have to be able to do. First one, let's calculate the molar mass. And sometimes we'll call that the molecular weight. And so what I would do is make a big show of looking up the masses of all of these. I'm going to use whole numbers when it's warranted, right? When it's close enough to a whole number that it won't throw us off with our 3 digits, right? And so let's just pretend I'm looking this up. So we've got 12 carbons, and each carbon, so that's going to be 12 times the mass of carbon. Well, carbon weighs 12 AMU, the average, 12.01, but we can round that. That is close enough to 12 in that case. And then hydrogen, we've got 22 hydrogens, so we'll take 22 times the mass of hydrogen, and I'm going to call that 1 AMU. It's 1.0079 or 1.008, but when you take 3 digits, 1 is close enough, right? That'll work just fine. And then we've got 11 oxygens. I usually put oxygen in parentheses, otherwise it looks like a number, right, when you're printing it. And so that would be 11 times the mass of oxygen, which is 16 AMU, the average mass per atom. And so then we'll just do this quick, and hopefully you can see that getting a little glare on the screen. There we go. 12 times 12 for the carbons, plus 22 times 1, well, we know what that is, plus 11 times 16. And then I hit equal, I get 342. So I get 342 AMU per atom, or 342 grams per mole. Same thing, right? 342 AMU is the mass of one molecule, and 342 grams is the mass of 1 mole of this substance. Okay, so we've got the molar mass, right? What if we were asked a question about getting the number of moles? So suppose we're asked, calculate the number of moles in 32 grams of sucrose. In other words, 1 sugar cube. How much is 1 sugar cube? So here's our conversion factor, right? 342 grams is equal to 1 mole of this compound. So to do the conversion, just like 12 inches in a foot, we'll start with what we're given. We're given 32 grams of sucrose. Now, I'm going to be careful. Now, I know this adds a lot of extra time when you're doing it, but it's important that you do this when you do stoichiometry. So I'm going to write the formula. And I promise you, as your coach, if you always write the unit and the identity of what you're talking about, you won't make mistakes, right? Because they've got to cancel out and it'll work. So that's grams. We're asked for the number of moles. So I need moles to be in the numerator and grams to cancel. So I'll take my molar mass, 342 grams of C12H22O11 is 1 mole of that stuff, the sucrose. And then grams of that cancel, and I'm good to go. And I know that I didn't make a mistake because I'm canceling the units just like algebra, just like algebraic expression. So 32 divided by 342, and I get 0.0936. I'm always going to include 3 digits because that way we won't have a rounding error in WebAssign, and that is moles of the sucrose, and that's the formula. Okay, so there's a lot of practice available to you for that on WebAssign for the chapter homework where you're converting from grams to moles. What about if we were asked to calculate the number of moles of carbon? So how many moles of carbon are in this sugar cube, 32 grams of sucrose? Okay, so that's the next example. Well, how can I do that? How can I get moles of carbon in 32 grams? Well, you know, you might think, well, I've got to figure out how many grams of carbon per mole of this stuff or something like that. You know, but that's kind of like the whole figuring out earlier when we were doing conversions, figuring out how many nanometers were in a centimeter. We don't really have to do that. We already have the moles of 32 grams. So we can start with that. Does that kind of make sense? And from that, we can figure out how many moles of carbon. Well, let's talk about how we would do that. So I'm going to start with what we just calculated, 0.0936 moles of C12H22O11. O11. And we want to convert that into moles of just carbon. Well, where are we given that? Well, it's the meaning of the formula, right? The formula means there are 12 atoms of carbon in one molecule of this, but it also means 12 moles of carbon in 1 mole of this. So we can write another conversion factor, right? We can write 12 moles of carbon are in 1 mole of this molecule. So it's going to be 12 times that, and oh shoot, I got rid of the answer on my calculator. If it was still there, I could just plug it in, right? Take it times 12. Not a big deal. All right, so that times 12, I get 1.12. Okay. Now, hopefully that makes sense to you, why you can do that. I think if they were round numbers, it would make sense. It would just be like counting. So we would say, if I had 10 moles of this sucrose, and you looked at it, you say, well, that's 120 moles of carbon, because there's 12 in each mole, right? And that wouldn't be hard to do. So you just have to apply those same things, but doing it systematically like this gives us a good roadmap to do it. And then in chapter 3, and probably only in chapter 3, and you'll never have to do it again, you're also asked sometimes how many molecules or how many atoms in things. And that's to get us familiar with using Avogadro's number. Okay, let's get this lined up. So what about another example? What if we were asked to calculate the number of atoms of carbon in 32 grams of sucrose? So calculate the number of atoms of carbon in 32 grams of sucrose. How can we do that? Well, I'm stumped, okay? I don't know how to do it. So I'm going to think back. Is there a relationship between atoms and anything else? Counting things. And that's our Avogadro's number. Avogadro's number. I just like to call it Avogadro's number because I like the guacamole joke so much. Anyway, bad puns are, you know, a sign of old age, I guess. I don't know. But so we've got that, right? 6.02 times 10 to the 23rd atoms of carbon is equal to 1 mole of carbon. So we know that relationship. Well, wait a second. Did we know how many moles of carbon were in the sucrose? I think we did. We had 1.12, right? So we can start with 1.12 moles of carbon. Now, if you had just had to do this without that, you'd have to go 32 grams of this, grams to mole, you know, you have to go through every step that we just did, and then take your moles of carbon, and then what are we going to do with this equality? We're always multiplying by 1, and so we're going to put moles of carbon on the bottom so that it cancels. 1 mole of carbon, and Avogadro's number on the top. And I'm going to write atoms of carbon just like that. Okay. Now, here's where there's usually a lot of people know how to do this. I don't know why the glare is so bad tonight. I must have the camera just tipped a certain. No, it's not that. Anyway, so there's usually a number of students who have calculator issues, who know, and I see this in questions that I get. I know that they know how to do it. They tell me in their emails or their posts on D2L what they're doing, and what they're doing is correct, but they're just having trouble with the calculator. They're not punching it in right. So let's show how to do that, okay? So I've got 1.12 times 6.02 E, always use that scientific notation button, And what did I forget what avocado's number was? No, I didn't. Anyway, times 6.02 times 10 to the 23rd. And I get 6.74 times 10 to the 23rd. 6.74 times 10 to the 23rd. And that is now atoms of carbon. All right. Well, hopefully these examples will help you with the Chapter 3 homework, and I will see you in the next set of examples. Thanks.